Okay, for our next video, we're going to talk about special products. Now, these are just shortcuts to multiplying binomials together. It's not necessary to absolutely use them, but once you do use them, you'll see they significantly shorten the amount of time once you recognize these patterns. So the first goal here is to multiply binomials by applying the pattern formed by squaring of sums, so squares of sums. And the second one is multiplying binomials by applying the pattern, that should be an n, formed by squares of differences. So in other words, we're going to end up with perfect squares. So here's the square of a sum pattern. So if we take a binomial and it has the terms a and b in it, so a plus b, and then we raise it to the second power, well, anything raised to the second power ends up giving you a perfect square. Remember that second power really means a plus b times a plus b, and here's the pattern that always comes out of it. You take the first term and you square it, and you get a squared. You take the second term and you square it, and you get the last term, which is b squared. And the middle term comes from the a times the b, which is ab, and then you double it, and you get 2ab. So this is the pattern you want to memorize. You can see we did that down here, and we end up with the first one squared, which is x squared, the last one squared, which is 9, and then x times 3 is 3x, but then when we double it, we get 6x. Okay, so they want us to square a sum. All right, so this is real easy. So we take the first term, which is x, times by itself, so you get x squared. Then we'll take the last term, which is 6. We will square it. I'm going to put a plus 6. That's where the b squared comes in. And the middle term comes from the two numbers multiplied together and then doubled. So x times 6 is 6x. And then I want to double that. Now we'll get a positive 12x. And there's my multiplication of that binomial without having to do the distributive or vertical methods. All right, we're going to try another one, a couple more variables, but that is not going to change anything. The first one is to take that and square it, so I'm going to square the first one. So 3g to the second power is going to give me 9g to the second. Then I'm going to take the last term and square it, and that's going to give me a positive 100h to the second. And then to get the middle term, 3g times 10h is going to give me 30gh. But then I got to times it by 2, so I'm going to get a positive 60gh, and this becomes my product of multiplying a number by itself here. The square of a difference follows the same pattern, and the only difference in these two is instead of having a plus in the second position, you'll have a minus. Now, why do we still have a plus back here? Because remember, that comes from the negative b times a negative b, and a negative times a negative is still going to give you a positive. However, when we do the a times the negative b, we get a negative ab, and the negative b times the a, we get another negative ab, and when I combine these together, I still have a negative 2ab. That's why this middle one's negative still. And the pattern exists down here, so square this, and we get x squared, square this, and we get positive 64. However, negative 8 times x is negative 8x, but when we times it by 2, we get the negative 16 in the middle. So we're going to go ahead and square this difference here. So we're going to take the first one and square it. So 7d to the second power is going to give us 49d to the second. And then we're going to take the negative 2f and square it also, because that's the last term there. And that's going to give us a positive 4f to the second. And to get the middle term, we're going to take the 7d times the negative 2f. We get negative 14df, but then we have to double it, so because we're going to see two of them, so we're going to get a negative 28df in the middle. This last special product here was not mentioned in the opening part of the video, but it's called the product of sum and difference, and you'll need to recognize these, especially when we get to the factoring part of this. You'll notice we have an a plus b and an a minus b, and the only difference between these two is one has a plus and one has a minus. When we multiply these out, we'll end up getting an a squared, a negative ab, a plus ab, and a negative b squared. Well, this middle section right here are opposites, and they cancel each other out of the problem completely. So we end up with the pattern of a squared minus b squared. And some people will ask, why do we have a minus sign here in the middle and not a positive? Remember, that comes from the b times the negative b, which is going to give you a b times b, which is b squared, but a positive times a negative is still a negative. So the product of a sum and difference, that's what this is, a sum and difference. This is the product of a sum and difference, and then later on we're going to need to know that it's actually called a difference of squares. So this right here is called a difference of squares, because you got two perfect square numbers with a subtraction between them, hence the name difference of squares. So down here you can see the pattern is super simple. Take the first one, square it, take the second one, square it, and the calculation in between is always a subtract. It's never going to be a plus. And we're done with that one. Okay, so let's do another sum and product of sum and difference. So the first one squared is going to give us z squared. Take the second one squared, and that gives us a 25. And remember, this pattern always produces a minus in the middle, so we put a minus right there, and we are done multiplying. All right, so we're going to try this one more time, but we're going to mix up the kind of numbers we have in here, but we're still going to follow the same pattern. So down here, we want to multiply this sum and difference, and you'll notice that I changed the position of the plus and minus. That's not going to make a difference because multiplication is commutative, so it doesn't matter what order I multiply these in. What matters is the pattern that you can memorize. So this first one says, take that first term and square it. So we're going to take this term right here and square it. And then 3y to the third power is going to give us 9y. And then remember the power to power, so 3 times 2 is going to give us 6 power. Then we're going to take this second number and square it. So 4 times 4 is going to give you the 16. And the pattern always produces a minus in between. So this is our difference of squares that comes out of the sum and difference product.